Hello and welcome from the product management team to today's session, What's New in SAP Datasphere, where we cover features and functions we introduced or updated in the second quarter of this year, so Q2 2023. My name is Klaus-Peter Sauer and I walk you through a big part of the session today. And so let's have a brief look at our agenda. We will cover in the first part updates in data management, data integration area, then followed by updates in the data and business modeling area, and then what we updated in the command line interface area, so the CLI, and then at the end we will give you an outlook on what to expect over the next few months. So let's get started with the first topics here in the data integration, data management area. And the first one is actually a long awaited one where we now introduce parallel child tasks in task chains. So that allows you to define task chains with parallel tasks, could be two or more tasks in parallel. We also introduced collectors to continue running when all or any of the previous tasks is complete. So that feature is long awaited, and we also follow that up in release 2023-13 with an addition to the task chains where we can now also include intelligent lookups in task chains. But without talking about slides, let's have a look at the system, how this is implemented. So in the system, I prepared a little chain here. So let's open it up. What you see here in the prepared task chain is that we can now parallelize. Obviously, I introduced like a few master data runs, then added an any collector, and then added a few more data flow runs, and added also collector there, and finish it off with a final load of a persisted view. So what you see here on the right hand side is the usual properties pane, right, with all the objects used in the task chain. You can then go and drill deeper into those. You see the run status. This has not been run, and as you're probably used to, the email notifications area at the bottom. So if we jump into the details, for example, on this master data attributes section, right, you see some more details that it's deployed, etc. More interesting is probably here the collectors. So if we select them also on the graphical canvas side, right, so you see that they have a certain label. If you use multiple, any, or all, you have a unique one. You see what are the involved objects, so the ones before, the ones after the collector, and you see the parallel task operator option, which you can change at any point in time, also later if you pick the wrong one or if you want to change the collector type. So what's happening here is with an any collector, it waits for the first finished job previously run, and the all collector waits, as the name suggests, for all to be finished, and then after the last one has finished, starts the subsequent job. We also briefly saw on the slides that now intelligent lookups are supported, right? So you see that also here on the left-hand side. They're showing up in the repository area, and we can now select them as well. Simply just drag and drop them either on one of the existing ones, or we simply drag it somewhere on a free area on the canvas. What we see, we get three options: replacing an existing task, adding a new task, or add as a parallel task. So by default, it puts a sequential order, right? I can also change that at a later point in time. I can also introduce with like the plus button here a placeholder for the next subsequent task. So if I do that at a collector, I would then also generate a parallel placeholder here. That's it with task chains. So then let's move on to the next topic with the remote tables. To Daniel, over to you.
It is the purpose of this video to show the recent changes in the remote table editor and the data builder. There are two new options to choose from in the remote table editor that let you apply changes to existing remote tables as well as create new remote tables based on existing ones. The first new feature is the support of the Save As button in the remote table editor that allows the creation of a new remote table with a new technical name based on an existing remote table that points to the same source object. Let's create such a copy. One reason to use the Save As button could be, for example, that one wants to apply different or additional filter conditions to the same source object, but keep them usable via separate remote tables. When using this capability, an information box is displayed in the remote section of the remote table editor in case there exist other deployed remote tables pointing to the same source object as the remote table one is currently viewing. Clicking on the link in this information box shows a listing of such remote tables. The second new feature is a change remote source option in the remote section of the remote table editor that let you change either the connection or the source object or both of a remote table via a 3-page wizard. On the first page, you can choose the connection for the remote table. Let's keep the connection that we have chosen before. On the second page, you can optionally choose a new source object, but you do not have to. Let's choose a new table. The last page gives you an overview of the changes that are going to be applied when pressing the Confirm button. Applying here only means that the changes are visible in the remote table editor, but we have to save the changes if we want to keep them. Warnings and message boxes help the user to understand in which state a certain remote table definition is after a certain change or action. Let's, for example, keep the connection, but choose another source object for our remote table definition, as I've done right now. Before confirming our change, we already see a warning that our change in the first step only affects the design time remote table and that a deployment is needed in order for the changes to take effect on runtime level. After we save our changes, there's a change in the status of the remote table that again points out that a deployment is needed to sync the runtime and design time version of the remote table. But it also gives us the possibility to restore the remote table definition based on the currently deployed version. Furthermore, validation messages are created to highlight the changes on the remote table object. There are a couple of things one needs to keep in mind when changing the underlying connection of a remote table. If the changes affect the remote source type, let's say from SDI to SDA, additional validation checks and actions are performed which could block the deployment. For example, in the SDI to SDA case, filter conditions are removed since filter conditions are not supported for SDA-based remote tables. The same is the case for partitioning on non-key columns in SDI-based connections, since this is also not supported on SDA side. As a last remark, of course, both capabilities can be combined. Overall, these capabilities aim to simplify the work with remote tables and shall give more flexibility while working with these artifacts. And that's it. Thank you for your attention.
Thank you, Daniel. The next topics are presented by Hannes. Over to you.
We have extended the scheduling option for small options, but hopefully it will become quite useful, and that is the pause option. So now you can pause a schedule, meaning the schedule will not be executed until on pause. Today you have to, or before this you had to either delete the schedule in order to temporarily suspend execution, or you had to do a little trickery with the time range selection by setting the end date in the past to pause the execution. So whenever you need a temporarily pause of execution of schedules, for example, for transport windows, because you want to bring in a larger transport which otherwise would hit maybe views which are currently being executed and therefore locked and cannot then import. So if you do achieve things like that, we have introduced the pause functionality. How can this be reached? It's fairly simple actually. So whenever you have a schedule that is executed, actually started right from the beginning, but if you edit your schedule, you have here the little slider of the pause functionality, and by setting it, it will pause the execution. And we can see that the refresh frequency now is set to paused. To unpause, you simply do the same thing again and save. From now on, it will be executed again. This feature itself seems to be quite cumbersome to reach, but this is just a prerequisite which we released in order to enhance the mass operations, which is a thing we're working on. That means you can select one or many objects in here and then execute the pause and unpause to stop entire spaces if you need, as well as we're planning to have in the tenant management section an ability to pause tenant-wide. But we need this pause feature itself, so within the pacemaker, to pause jobs in order to either mass enable it or tenant-wide enable pause. And this is now the preparation for pause. I know it looks a little bit cumbersome today, but it will improve.
And then let's go to the first user stories in the data modeling section. And I have brought two user stories which both relate to the import metadata. And the first one is that we enable now the import of metadata for CDS views from S4 on-premise systems. Before we only had S4 cloud. It requires, because the S4 on-premise system, especially the older ones, do not have the season exposure service required to give us these metadata. It requires a node to be installed that basically provides the infrastructure to expose those metadata. And there's one slight difference. This node does not have the same full feature set capability as the season exposure service, so it will only basically deliver the metadata for the entity you're importing. It will not bring the entire model of S4 clouds. This is still a pending piece. And if we look at this, I'm logged out. If we look at this, how this works, if I go to import entities, for example, in the repository explorer, I have now the S4 cloud tile, and it shouldn't show me only spaces that have S4 cloud connections and that I am assigned to, so that I have access to. Hopefully. And then I can choose my connections. I can't remember which one. That was cloud, my mistake. I want an on-premise connection. Irritate it. Okay, and then I can basically select my source connections. And here it will typically fail if the node is not installed, because at this point of time, it will connect to the system and try to retrieve the information. Now we actually see IC entities. And I will combine this actually with the next user story, because the next user story allows multi-select in this same dialog. So before I could only select a single entity, now I can select multiple entities. So if I want to bring more objects over, this makes it slightly easier. And it's very simple. Instead of having only one, I could only select one. Now I can select multiple ones. And if I do this, Obviously, the more the select, the longer it will take because it has to grab more metadata. But if I select, it will now resolve me. You see here, actually, you get a second entry here where you can select the objects you have picked, and it will then bring over the respective objects here and show you the ones, but if I'm not sure if I've selected complex ones or not. And then if you start deploying, I'm not going to do this now, it will bring all these entities over into Datasphere.
Thank you, Hannes. And then let's move on to the next topic in the modeling area. Over to you, Jan.
With this feature, we're introducing currency conversion after aggregation as an unmeasured type in the analytic model. This is solved via the currency conversion tables that are also known as T-core tables. They need to be imported first from an SAP S/4HANA or cloud on-premise system or from an ABAP connection to any NetWeaver system. And after those tables are present, you would configure your currency conversion measure. And obviously the properties, as you see them on the screenshot, leverage the T-core table. So the target currency is coming from the respective table, and so the exchange rate types and the client and so on. And then at runtime, you would first aggregate the respective measure. Here it would be the price in their respective currency, and subsequently the currency configuration happens. And so there's really only one configuration happening. And so in terms of rounding errors and also runtime, this is preferable as well to the currency configuration on the data layer in the respective view, where you can do it, but on a record per record level. So let's look at how this looks in the system. So here we're having an analytic model, and here we are introducing a new measure type, a currency conversion measure. I already created this one, so you see this based on the small dollar sign here. And then the dialog looks exactly as you just saw it on the slide. So there are the target currencies that are being pulled from the respective T-core tables. Alternatively, if there is a dimension, hence some column that would give you the target currency, you could also pull it from there, and that dimension needs to be flagged as a currency column. We'll see the underlying model later on in detail. Reference date wise, you can take it directly from any dimension. Alternatively, you can set it to a fixed date, so fix that, or always choose the current date here. There are various exchange rate types that goes quite a bit level deeper into the mechanics of these currency configuration tables, and so you would choose one here, and then there are some advanced settings as well, like the client, the way error handling is handled. So if, for example, no code is available for the or no currency conversion rate is available for that date, for that combination. And so if we then look at what this gives us, then the preview shows you the results of this modeling here. And so initially, when you look at it, there's data coming from various transactions happening in various local currencies. So there is really no way of aggregating them properly. Nonetheless, in the respective columns, they can be totally converted in the aggregate result. So when you look at this, for example, here, we would see that there are a couple of transactions happening in Australian dollars, $130 worth of those, and those can be translated on the booking date to $67. Well, the same token, the Deutschmark could be translated to those 90 here, or the US dollars can be translated over to here. And a couple of background information on this that you might want to be aware of, because this is the underlying fact here. So if we look at what the data gives us, then as I said, there are a couple of bookings happening, some of them in US dollars, some of them in euros, and so on. As you would have it, it's real transactions happening in their local currencies on various booking dates, and these are exactly those dates that are being used. What is important is that you would need to sort of annotate your data accordingly. So the measure that is being converted is actually an amount with currency, and it pulls its currency from this currency column. And that this currency column is exactly this other column that is flagged with a semantic type of currency code. So these mechanics are required in the configuration previously, so that the system can then later treat those columns according to their semantics. And if you don't have a currency column, you can totally create a calculated column and set this to fix, but it needs to be a currency code. Yes, so that's it. With this feature, we're adding value help for expressions and graphical views. And so expressions, we mean filters and calculated columns and having clauses of aggregation nodes. And what this means is that there is, as you see, an insert values button now for expressions. And when you started developing that expression and place your cursor at the right point in place in context, the respective expression is passed, the respective column is identified, and for that column, the possible values are identified, and that entirely happens in context. So when you had previous, I don't know, joins or unions or other filters that happened that affect the possible values, then this is considered, and only the values possible in that context are really shown. The first 100 values are being retrieved. If your list is longer than those 100, you can always use the search and sort of downsize that list. And if you're having in operators that take several values, those you wouldn't, like here, have checkboxes, or you wouldn't have radio buttons for single values and checkboxes for multiple values depending on the operator. And so as you'll see, for certain operators, you will need to do some subsequent formatting. So we don't take care of, say, adding the brackets. So you're still the owner of the expression that you're saying there, but finding the respective values in context, that's entirely up to you. That's a graphical view feature. So we're concentrating on all things in the graphical view, and we are not having this yet for analytic models, and same for SQL views. And for any and all, it doesn't really make sense. For binary and UUIDs, we don't have that. And obviously, this spares you from spelling mistakes. So let's see how this works. Here we have a simple view, and let's walk through the various editors. So I have here a first filter expression, and I want to check if my column here is, here I'm talking about products, and my product is between, and now I insert the corresponding values, and I want to check that it's between this guy and this guy. And so that expression now is totally valid, and I could go on and say build a subsequent calculated column. That's my other expression editor that I could use here, and possibly I would check on my best seller, and I happen to know that my best seller is my product with the corresponding value. And now the respective values for this node are identified. And that's important to understand, especially for more complex scenarios where possibly you have a large graphical view with many unions, joins, filters, and so on. And the list was quite a bit longer before, and now I'm filtering on this. And here I should possibly not use that, but rather an expression like here, like case when. And so here, if I have product equals, and now comes my insert value statement. So the shorted list here, and then it should be yes, and otherwise it should be no. And then subsequently, I could from here have a aggregation node, and this aggregation node itself could build an expression. And now I possibly want to use another column, like here the opportunity. And if I check here for the respective values, again, the expression is passed, and I'm seeing the possible values now in this context. And so here, those are the possible opportunities in this context, and I can select one, and now I'm done. And so this helps me from many stupid spelling mistakes, and we're pretty proud that this is finally available.
With this wave, we're introducing a new semantic usage that we call fact, and that essentially replaces the analytic dataset, which in turn gets deprecated. Facts are, in all their essence, exactly like ADSs. So anything that you know and cherish around the modeling, the adding of semantics, the associations, the way you handle authorizations, all of that, the whole editing experience, all of that is entirely the same as for analytical datasets. But there is one crucial difference, and that is what happens on deployment. Because on deployment, only the view part, meaning the SQL part of that fact, is deployed. And so this means this object cannot be consumed directly by SAC. And that really is not a loss in and out of itself at all, because the analytical consumption by SAC is something that you should do in an analytic model anyways. And so by this, we consciously split the relational modeling, meaning bringing tables and views together through unions and joins and filters, calculate columns, all of that. We separate that part of the modeling that we're doing in the fact and the analytic modeling. So the additional calculated measures, the restricted key figures, the way you handle prompts and filters and so on. All of these that go into the analytic model and that prepare the consumption of the data in SAC. So, and in ADSs, and we'll see this on the next slide, these two aspects, relational modeling on the one hand side and analytical modeling on the other hand side, these were done in the same environment at the same time in the same object. And this is somewhat suboptimal, both from a user experience standpoint and from a modeling architecture standpoint. Nonetheless, ADSs are just deprecated. They continue to exist. So anything that you do with them in terms of stories, consuming them, all of that entirely stays the same. And so, and analytic models can still consume facts and analytic data sets as their fact sources. And so customers can entirely continue to use their ADSs, but it would be good to migrate at your own pace, at your own disposal, to a fact consumed by an analytic model. What we did introduce to make it clear that ADSs are no longer the go-to way, but rather facts plus analytic models are for modeling, we're introducing warning messages and info messages depending on what object you have in front of you. But an ADS is automatically receives an info message that you're seeing on the top left, on the bottom left. And also facts can be exposed for consumption, but what this means is that the corresponding HANA view, hence the relational object, can be consumed. And that can be consumed via SQL and OData, just in the same way as ADSs are. And this all in all leads to a much cleaner and more separation of relational and modeling and with clear best practices. So before we go into the demo, let's quickly see what this means on the deployment side. So on the left-hand side, you see the analytical data set, and that brings together semantics, and we'll come to that, what this is, and the SQL part. So all that you model in the main pane here, that's essentially a graphical or SQL way for expressing what the view does. So the unions, the joins, the filters, the calculated columns, the projections, all of that essentially is just a SQL statement. But on top of that, within the same editor, you're actually giving additional semantics on what to do with this data. And this is already given business names to fields, something SQL doesn't know and understand. Semantic types of columns. This column is not just a 3-character string, but it's a currency code. And so upper layers should look at it as a currency code, or as a language, as a text for some other column. And the same is true for this differentiation measures and attributes, something that the SQL object doesn't aware of, but you, during analytical consumption, will be made aware of. Also associations from fact to dimensions, from dimensions to hierarchies, to texts, or to yet to another dimension. All of that is something that that is business semantics that you put on top of that relational object. And now on deployment, something very, very important happens. And that is that the SQL bit of the analytical data set, that is deployed to a SQL view, and that semantics is actually taken and it's translated to a cube as well. So there are really 2 objects when you deploy and expose analytical data sets. And the semantics is translated in a standardized way. So there's no decision on your end which fields are exposed, which dimensions are exposed, what additional measures you would like to actually have, meaning calculate and restrict key figures, what additional prompts you want to have for filtering, for and so on. But if you do instead with facts and in models, the fact really on the design term side looks exactly like your ADS did. So it has SQL and semantics, and it's done in the same editor. So from an editor perspective, nothing changes. But when that one is deployed, only the SQL bit is deployed. So this arrow here is something that is only happening in the ADS. And so instead, those semantics actually inherited upwards to an analytical model that does all the analytical modeling thing in a known editor that has all these benefits that you know and cherish. And so instead of having just a default cube that SAC sees, it's a very consciously designed cube. And this is what we're promoting as best practices. You can, of course, continue to put your analytical model on top of the ADS and stay with that, and just not use this ADS generated cube, because the analytical model cube is better and more appropriate to what you're trying to achieve, but it's totally possible. So let's see how this looks in the system. So we have an extremely simple ADS here, and when you're looking at it, it's just at the end of the day, a select star on that table. But on top of that, you have all these things that I mentioned, the semantic usages of and the semantic types here of columns, and the same is true here for the attributes. All of that that is something that is identical between ADS and fact. And by the same token, also here, these associations that you drew, those continue to exist whether you're in a data set or a fact. But here, this ADS, it spells it out, it's deprecated, so there's a corresponding info message on this existing object that goes away when I turn this into a fact. And from that on, nothing changes. You see, the editor is just as we had it. But on deployment now, it's only that SQL bit that is deployed, and all of this additional semantics is consumed in an analytic model that you put on top. So having said that, one last point that I don't want to shy away from in this is making clear what this means for a migration side. And as I said, none of this is crucial that you do this, because your existing objects will continue to run. It's only relevant when you want to leverage the benefits of the analytic model from a capability standpoint, and if you want to sort of make it clear in your modeling that you're adhering to best practices and separate facts and the analytical model in and out of itself. So let's take a starting situation of an ADS, we call it A, that is consumed by a story S. And so ideally we want to come to a situation where this same object is instead classified as a fact. There's an analytical model B that consumes it, and there's a story that consumes this B instead. And so we're replacing so instead of talking to the ADS cube, so if we go up here, instead of talking to this cube, your story talks to this cube. And this guy is classified rather than as an analytical data set, it's classified as a fact. So there's one new object, SAC starts talking to this other one. So what are the steps that are required for this? So you want to have this analytic model in the first place. So you take the analytic model and you build it on the ADS. As before, since we launched analytic models, they totally work on ADSs. So if you then add all of the attributes of the ADS and the measures, and also the first level dimensions, the cube that you're essentially designing at this point is exactly like this default cube that the ADS gives you. So these are really the same. You can add stuff later if you want, but so far it's a migration thing, so you want to have this. So then you save and deploy B. And now an interesting thing happens, and that is that this story doesn't find it so easy swapping from one model to another. And that has nothing to do with ADSs and models, but even if you have two ADSs of the same structure, getting your story from one ADS to the other isn't straightforward, because the story sort of keeps these references pretty tightly. And so what you do here now is that you add this new analytic model to this story as a new data source. And then you would copy as part of the migration, because there's no sort of replace action in the story editor. So all the pages that you want migrated, you copy them within the story. So you have each and every widget and twice, once pointing to the ADS, and the copy points to the ADS as well. So the old ones you have always for reference, and then you go through these widgets and sort of rewire them from A to B. That's something that is unfortunately not automatic today. So each widget is rewired from the ADS to the newly created analytic model, and you can always double check whether things look the same, are the same, because you have the old one that you copied things from. And so you end up with all these widgets migrated, you test that, and if all looks good, you can actually take those old references and delete them. And once that is there, the ADS is really no longer required, because there's not even a single widget pointing to it. So you can just as well get rid of this default cube and say, I'm happy with the ADS really serving as a fact source only, so I classify it as fact and I deploy that. This sort of gets rid of this default cube. It redeploys that same HANA view, and then that's it. And then you open your analytic model, make it aware, deploy it again, and then you're through. So this is the way that you need to follow for those situations where you want to benefit off the goodies that the analytic model gives you, and where you want to sort of get your architecture adhere to the best practices for really separating out relation modeling in facts and analytical modeling in analytic models. And that's it. Thanks for listening.
Thank you, Jan. And then let's move over to the next topic, transport of business layer objects. Over to you, Amok.
In the release 2023.13, Datasphere now supports business layer objects in the analytic content network export and import. With this new functionality, now it will be possible to export and import business layer entities, facts, consumption models, and perspectives, similar to the way that data layer objects can be exported and imported through the content network. The functionality will be available in the same dialog box where data layer entities are to be exported. Let's take a look at that in the system. For this demo, I've created a few artifacts in the business layer, mainly the consumption model, perspective, a business entity as a dimension, and a business entity as an analytical data set. Both my business entities are based on the data layer entities, mainly v_products and v_sales order items. What I'm now going to do is I'm going to export this all into a package. To do this, I'll start with export here. Now, let's create a new export. Now you'll see in the list here, along with the data layer entities, we also now see the business layer entities, mainly the business entities along with their versions, and the consumption model and the perspective as well, in addition to the previously available data layer entities like remote tables and views. I'm now going to select my top level perspective, the one that has all the other items as its base, and click on next. What this means is I expect not just the business layer entity but all its dependencies as well to be exported. For this test, I am going to export and import into the same tenant to make it easy for the demo. To help with this, once the export is completed, I will move over to my data layer and my business layer and delete all the artifacts that are part of the package to make sure that we are able to demonstrate the deployment and import. You can look at the process. Similar to what happens when you are exporting and importing data layer entities, business layer entities are also being supported in the same manner. What we need to understand here is that in the first release, we are still not supporting folders within the business layer. If any objects are in the context of a folder, while exporting, they will be imported to the root level during the import process. Additionally, this functionality is available primarily in the 2-tenant mode. Now, we have finished the export of our package. It should be now available in the export link list here. Once it is, we will move over to our, there we are. Now we will start from the business layer and come down to the data layer to make sure that there are no dependencies on top. So now I've cleared my business builder and then the data builder as well. Now I have a clean slate during the import, and any and every object set now will be visible after the import will be coming through the package that we have exported. I will now move to the import section where I should see the package that I've exported previously, and it should be available for an import. Please note that there's a time difference between the import completion that you see from a content network perspective and the actual sync of the repository. The lead time will be somewhere between a few minutes, and after a few minutes, when the import completes, you should be able to see the objects in your data and your business layer. This is the package that we had exported. I'm simply going to import it, and I'm going to say deploy after import, so that it imports all the data layer objects and also deploys them. Additional thing to notice here is that perspectives, even though they will be imported, will not be deployed. In the first release, they need to be deployed manually after the import completion. You can now again check the progress here at the top. Now we see that the content network has provided a notification that the import is completed. Now let's move to the business. Now let's move first to the data builder, and we see that all our objects have been imported and deployed. And to the business layer, we see that the artifacts are now available the way that they existed on the source. If I open the perspective, as mentioned previously, the deployment status is set to not deployed because The deploy after import does not work with perspectives. For now, we deploy it manually, and then we'll see that the status gets updated once it is deployed in your list of perspectives. Once this completes, we'll be at the end of my demo. There we have, the status is now changed to deployed after I have manually deployed my artifacts, which means that now this perspective is ready for consumption.
Thank you, Amok, and then back to Hannes for the first topic on the command line interface.
With this user story, we enabled the CLI to call task frame features. In our case, specifically with this story, it's the consent management, the task chain executions, as well as the logging and status retrieval. The idea behind is that you can use the CLI as well as the API to execute task chains, and with that indirectly also execute remote table snapshots, view persistencies, intelligent lookups, and data flows, either in other scripted tools or manually through the command line. We are additionally working on publishing these APIs in the SAP Business Hub so that they're publicly documented and can be more easily integrated into tools like the UC4 central scheduling tools. So how does that work? If I have a system like here, my QA master system, and a task chain, for the demo purposes, I have here in my space Kyle H. I can now use the command line tool where I'm setting a host, and I see, okay, yes, the host I'm currently working with is my QA master. I did this so I don't have to have the H command for host every time I want. I obviously need to log in, and I'm using the secrets file concept so that I don't have to go forth and back with the browser and taking the individual tokens. Now I can do multiple tasks as well. Let's look at the consent first, so I can get my consent and see if I have something. My user obviously has something given already because I've been running task chains for quite a while, but what I can do is I can revoke it. And if I would run the get command again, I see that my consent is no longer available. And if I go out of here, I should see these yellow. Oh, I don't see the yellow. Or yeah, I see the yellow here, the yellow bar basically that I need to give authorization. I could now click here on the bar, or I can simply go back into the tool and give the consent again, which will result in the bar hopefully disappearing. And if I do a get again, it should show me that my consent is back available. Good. Let's look at task chains. How do I start task chains? I can start task chains by using the Datasphere task chains run command, and I have to give it two options, the space options I want to run it and the object I want to run. So in my case here, there's demo task chains and my UI is set to show the technical names. So if I do this, I get back a log ID. So this is the log ID that I can retrieve the logs of the task chains back. And you see now in my browser that my task chain is running, and I see here the same log ID as in the CLI. So if I want to monitor my task chain, I have two options available. Basically, both is the task logs where I want to get it, and I have to pass the log ID. So I need to adjust this to 7.4, and it will show me as expected, that my task chain is running. So now I could basically cycle over it and check until when it is done. Or if I want more details, I can go in and increase the info level by asking for details, and it will basically output me what I see on the screen here. So I get on a task chain first in the children's section here all the different nodes that are executed in this task chains, and you can see in here I also get the log IDs of the individual items. Let me find one that's not triggered. Let's see if now something is triggered. Yeah, if something is triggered, here for example this add, I have a log ID here as well, so I can recursively basically go into that and also check for each individual task I have run the logs, and that would basically be the same thing as if I click in the UI here on an element, and there's no messages in here, but if I would basically go into this remote table and check the log of this individual remote table. Oh, I need to refresh, sorry, here. And then I would get the same messages I would get now in here. You see there's a 95, that's the same log as I just pulled out of here in my second request. So you have the ability not only to get to the logs of your task chain, but also to the logs of the individual tasks inside of the task chains. There is one more object available, one more ability available. I can also go in, and if I don't know the log ID, I can list the log ID of an object. So if I ask this, it should show me all the different logs. So basically this would display me what I normally see here under the runs section in my data integration module.
Thank you, Hannes, and over to Florian for the second update on the CLI topic.
Hi, the feature I'm showing you today is actually no new feature, but it is rather a rebranding of an existing one. And as you all know, the command line interface we introduced already for Data Warehouse Cloud back then. And now with the release of SAP Datasphere, obviously the old abbreviation DWC is no longer valid. This is why we changed all the commands now to the abbreviation Datasphere plus the command. And yeah, the old commands will still stay valid until the end of the year. But with this step, we are now make sure that we have a consistent naming convention for the whole product. There are already many blogs in place about this topic, and yeah, the new package is now already available at npmjs.com for you to take a look at, yeah, with all the information you might need. So yeah, if you are interested in that, I invite you to take a closer look now. Yeah, to prove that it actually works, I already logged in using the new commands. As you can see here, I did the cache init command as well, and now I just type in here datasphere -help, and you can see, okay, it works now, as you are used to with the old commands, but now with the new abbreviation SAP Datasphere.
Thank you, Florian. And then let's go to our last topic of today, the Outlook. So over to you, Stefan.
My name is Stefan and I'm a product manager for SAP Datasphere. In this slot, let's look at the innovations we have in store for the next half of 2023. But first, we will highlight some recent innovations that were released this year so far. Of course, what we see here on the screen is only a small selection of innovations. In spring this year, we have released the catalog for SAP Datasphere, offering cataloging capabilities for SAP data. It also offers embedded lineage to trace the flow of data. If SAP Datasphere is connected to an SAP Analytics Cloud tenant, the embedded lineage even extends into SAP Analytics Cloud, Hence, we have a joint lineage capability here. But what does that now mean? For example, we can check whether all data assets contributing to a certain dashboard in SAP Analytics Cloud are well maintained, or whether some are outdated and should be replaced with maintained versions. That way, SAP Datasphere helps us to establish trust in data and also trust in decisions. Flow, also released in spring this year, SAP Datasphere enables mass data volume transfer. This mass volume data transfer is of course allowed via initial and data replication capability. And it's all about one-to-one data replication, and these data replication jobs or replication flows can be run in parallel. There's also an embedded monitoring capability in SAP Datasphere available. Okay, but now moving on to what is coming this year. We will release the space-dependent permissions later this year. This will also allow users and especially administrators of tenants to fine-tune permissions for users per space. For example, let's consider a user, John Smith. He is a user in the space finance, but also in the space sales. In space finance, John Smith has permissions to model and view data. But in the space sales, this user, the same user, John Smith, only has permissions to view data. This is currently not possible in SAP Datasphere, but it will be enabled with space-dependent permissions later this year. Looking at semantic onboarding, SAP Datasphere will allow to ingest, hence onboard not only SAP data, but also all the semantics around it in such a way that manual rebuilding exercises should be reduced or can be completely automated. It focuses, of course, on data products at first, as well as entity import and content. In the end, it is a unified entry point for semantically rich model generation and import into SAP Datasphere. Based on our partnerships, the integration with and towards Collibra will materialize itself in the second half of 2023 as well, with API exposure of catalog asset metadata, for example. Another exciting innovation coming later this year is elasticity with elastic compute nodes for SAP Datasphere. This will allow administrators in the end to operate smaller configuration sizes of their SAP Datasphere tenants. Because with elasticity, we can now cover peak consumption times or scenarios with elastic compute nodes that we can on demand add to an SAP Datasphere tenant. And once the peak consumption timeline is over, we can just revert back to the baseline configuration of our SAP Datasphere tenant. And again, this will allow us to operate smaller tenants. And if there's more demand for consumption, then we just add an elastic compute node to the tenant. Looking beyond 2023, we of course see more updates for the analytic model, for example, with, let's say, multi-fact modeling support. The catalog is also continuously getting improved and more capable with an expanded crawling, reaching to more source systems. And also, of course, the partnership with Collibra will further materialize itself in the system. Another partnership, the one with Confluent, covers streaming/Kafka scenarios. This will also come into strong effect in after 2023 or by 2024. And as we did in the past, the tight integration between SAP Datasphere and SAP Analytics Cloud will continue and even accelerate.
Thank you, Stefan, and many thanks to all our speakers today for preparing the content. The slides are available in the resources section for you to download. And thank you for being with us today, and see you next time. Back to you, Lacey.